Good morning, everybody. So, this is the culmination of Investigation 2. Today is a little review, so we're going to have both book work and some worksheet work, but it's not going to be too overwhelming. Just get ready for tomorrow's quiz, which is going to be on factoring, solving quadratics using factoring as well as expanding it, finding equivalent expressions, and understanding axis of symmetry from the vertex of the parabola. So today is all about graphing to an extent. The beginning part of the investigation is just analyzing graphs based on the equations. So I got an example over here that looks kind of like the book we're going to be doing today. So over here I have scattered graphs. Over here I have equations. Now these graphs match up with these equations, and I'm going to teach you guys how to figure out easy ways of going about doing it, just so you guys can always do this. So first things first, I got y equals x squared. I got y equals parentheses x minus 4 times x plus 2. I got y equals x times quantity of negative x plus 2. I got y equals x minus 2 times x minus 2. And I got y equals x plus 4 and x minus 4. So down here, I'm going to do a little bit of work so you guys I can show you how to think through this appropriately. But first things first, let's try to get easy ones out of the way that are potentially going to require a little amount of work. But again, use that thinking that's necessary. Y equals x squared is what's considered the parent function. So this means literally when x is 0, y is 0, and the vertex of this one, this is kind of easy. I'm hoping it's easy. The vertex of this without any work needed is exactly 0, 0, because when x is 0, y is 0. And this graph down here is the parent function because it goes right through the origin and it only touches the x-axis once at 0, 0, proving that true. So this is number 1, okay? That's an easy way to think through it. I'm looking down here. I'm going to just go in order now because there's nothing else that is, as of right now, super easy for you because you just began learning this. I'm looking at this. Now, I got my solutions for this. So now I'm going to look at my factored form and know that my solutions are the x-intercepts. Don't forget that. Remember, solutions, I'll be erasing this in a minute. Solutions are the x-intercepts. Don't forget that. I'm trying to make this easy for you guys. Okay? It's a messed up E. And I'll do my best to not misspell anything today based on some conversations yesterday. So my solutions here, which are my x-intercepts, are x equals 4 and x equals negative 2, based on what we've been practicing thus far with quadratics. So those are my solutions. So I'm looking for x equals 4 and x equals negative 2. And I can see my solutions are proven true right there. I'm just going to double check real quick. Well, I got a 4 there and a 4 there. We'll figure that out later. But I got a negative 2 and a positive 4. So I can see really quickly that number 2 is part B. And if I want to take it one step further to prove that this point down here looks like this is 1 and probably negative 9 or 10, who knows? Let's just make sure you guys know this because this is another part of today's lesson, is understanding vertex. So if I were to, and one of the questions in today's work is to ask you to not only identify the solutions, it's also going to ask you to expand. So let's do that. So now if I'm doing this one down here, this is number 2, I'm going to just do the FOIL work right away. So now this goes into y equals x squared times 2x minus 4x makes negative 2x, and then negative 4 times 2 is negative 8. So this is what's considered as expanded form, okay? Now, I want to take it one step further to find the vertex, and again, this is something I'm going to go over a little bit in the lesson. Remember, I do x squared minus 2x, parentheses, keep that guy outside. Half of negative 2 is negative 1, negative 1 squared is plus 1. I brought a positive 1 into this that wasn't there originally. I must take it out. So now I got x minus 1 squared minus 9. So my vertex, can we read this? I believe so, yep. My vertex is going to be exactly at 1 comma negative 9. And this looks to be about true, so I can assume B is number 2. That's a messy number 2, but you know this is number 2. All right, so I got that out of the way. And that's how I want you guys to think through this. And while you're doing this, just to get work out of the way based on some of the questions in the investigation, you should probably be expanding it while you're doing this in the first part of the investigation. Now, one thing further. Now let's go to this one. So again, because I want you to always expand it so you guys can see it, right? So now this is number 3. And I got y equals, this times this is negative x squared, and this times this is positive 2x. I also know my 2 solutions based on this right here are x equals 0 and x equals not negative 2, because this is already a negative. If I input negative 2 with x, this says negative 2, which is then a positive 2. Be careful. X, the other solution is actually x equals 2. So I got my solutions at 0 and 2, 0 and 2. I got 2 right there, and I got x is 0 right here at this, but I'm supposed to have crossing the x-axis at 0, not x equals 0. All right, it's got to be crossing x-axis at 0. And this one right here is making that true. And the nice thing about this also is this is negative. This is an upside down parabola, so hopefully by now you're catching on to this. This is obviously number 3 because this is the only upside down one, so that holds true for this. Going on, number 4. I only have one solution for number 4 because they're both the exact same factor. So my solution is x equals 2. Okay? My solution is x equals 2. What's up? You're moving? Give me a second, okay? X equals 2 is the solution. Now, this one's nice because this means the x, this is only crossing the x-axis once, just like this one was, but instead of it crossing at 0, it's only going to cross the x-axis at positive 2. And I can see right here that this one is positive 2. And I went ahead and I put this y-intercept here just so this makes sense for what we did yesterday. I'm going to expand this right now. So number 4's expansion is right down here. So this is x squared, negative 2 makes negative 4x, and this makes positive 4. So we already know this one lines up with number 4, okay? Because this makes it true, and also this also makes it true because my y-intercept here, and again, I didn't draw the dashes, but this is meant to be 4 because when x is 0, y is equal to 4. And last but not least for this is number 5 right here at the bottom. Obviously, we know that it's the last one available, so number 5 has to be this one right here, which is number 5. Now, another way to look at it is I got my solution at negative 4 and I got my solution at positive 4. The solutions here are x equals negative 4 and x equals positive 4. Again, expand this. This will look like yesterday's work. I got x squared, negative 4, positive 4, cancels off your middle term, and this is minus 16. Look at this. Your vertex is the y-intercept at negative 16 all the way down there. So this will hopefully carry you through the thinking behind how to work through the investigation today, because that is all I'm going to assign out of the book. And then when I get back in 1 second with some more examples, I'm going to go over solving by factoring and also completing the square. So give me 1 second. Okay. So I got 2 questions I'm going to do here, which are straight off of the worksheet I give you guys today. You're going to be doing, just so you guys know, on both worksheets, because it looks like a lot of work, but you're only doing multiples of 4. So 1, 4, 8, 12, 16, 20. All right, that's all I got to do. So on both worksheets for solving by factoring and also vertex, one of the worksheets says vertex of the parabola. So I'll do this one first. I want to solve by factoring. A little review for you guys. What multiplies to negative 20 that also adds to negative 1? So right here, I got b minus 5 and b plus 4. So my answers, because I factored that quickly, I now know my answers to this particular quadratic. I got b equals 5 and b equals negative 4. That is this one. These ones are easier because your first term, your a of x, your first term in the quadratic is 1. These are always the easiest. This one's a little more challenging, but I really want to push you guys today and make you factor something like this, okay? Now this one's not that hard because this leading term is prime, so I know that my only factors of 5 are 5 and 1. So that means I got this, okay? I'm trying to model how to think through this appropriately. I'm looking at my quadratic. If this is positive and this is negative, I, no matter what, have to have negative here, okay? Now I'm going through my Rolodex of, my multiples of 60. I got, 160, I got 12.5, and a lot more. I got 610, 230, and I'm trying to think, which one of these add to negative 35 when they're multiplied against 5? So I'm thinking about this. I'm thinking, well, if I put 12 here, that makes this times 60. And if I put 5 here, that's not going to add to negative 35. All right, if I put 2 here and 30 here, 30 here and 2 here, that's going to add, that'll multiply to positive 60. But that's, if I put 30 here but 2 here, that's going to be 10 plus 30, that's going to be negative 40. That's not going to work. How about 20 and 3? 3 here, that's 15. 20, that adds to 35, perfect. So if I got 3 here and, 3 here and 20 here, that'll multiply to positive 60, negative 15, and negative 20 make a negative 35. So there are my factors, okay? Now this solution is real easy. This is obviously x equals 3. Down here, you gotta do a little work. So I got 5x minus 20. I'm trying to solve for x to make this whole thing equal 0. So I just add 20 to both sides, and I got 5x equals 20. I divide by 5, I got x equals 4. There are my two solutions. This is the kind of work you're going to have to do in today's work. This is also an example off of the worksheet about vertex, and I specifically am asking you, find the axis of symmetry. In order to find the axis of symmetry, you've ultimately got to find the vertex. So again, this is something we've learned and worked on, but I know a lot of you are making mistakes on just small details, hence why we're practicing it again today. And you will see this on tomorrow's quiz. So let's go ahead and do this. I chose a hard one because I want you guys to know we factor out this -2 of only these two terms, and that's it, okay? So I do this. I got y equals -2 on the outside. This is x squared, and I do 8 divided by -2, and I get -4x. And then I got -12 right there, okay? I take half of this, -2, I square it, I get +4. Now remember, I don't take out a -4 right here. I brought in this times this. I brought in really a -8 that wasn't there originally. A -8, now I take out a +8. So now this is y equals -2. I got x minus 2 squared. This plus this is -4. So your vertex is going to be +2, -4. That's your vertex. Your axis of symmetry is whatever the x coordinate is of the vertex. So your axis of symmetry is, the equation is x equals 2. That's how you're going to be doing this, because these are some questions you're going to see throughout today's work. So also make sure you come see me for any questions you might have, and I will be sure to answer them today at 1 o'clock. Thank you.